This conference will now be recorded.
Okay, good evening everyone. Is my voice audible? Please respond. Okay, thank you guys. I think many of you are from the previous batches like IoT and embedded systems, and you are familiar with the GoToMeeting platform. I need all of you to edit your names. Okay, just maintain your college roll number and along with your names. Okay, no need to remind for so many people. Okay, if any new person is attending the class, just make sure that your name is present along with your college roll number. Okay, and maintain the same
Yes,
name
sir. Yes.
during. Okay, thank you for responding. Maintain the same name during the 12 days course. Okay, so that your attendance will be considered correctly. Okay, I think all of you know why you are here now. I think many of you have done several courses like IoT and embedded systems. Okay, Python. Okay, like that. In APSSDC, no need for any introduction of APSSDC for you. Okay, now you are here for learning PCB designing, right? Okay, can anyone define PCB? Please turn on your mics and you can respond.
Printed circuit board, sir.
Printed circuit boards.
Okay, thank
Printed
you.
circuit.
Okay, I don't want the full form of PCB. Can anyone define what is a PCB is? Okay, I don't want the full form of PCB. Just what does it do? Can anyone define it?
Electronic circuits are connected in the board.
Okay, good, Mr. Nasar Reddy. Thank you. Any more answers?
It is an electronic component, sir.
Okay, that is not a component. Okay, you need to correct your answer. Okay, any more answers?
Any circuit can be made on the printed circuit board without any wires.
Okay, good, Mr. Prasad. You're almost there. Any more answers? Okay, many of your friends have given some answers, right? Like, what is a PCB? Some components can be mounted and some circuits can be designed on a board. Okay, without someone said that without using any wires. Okay, we will move on to the next slides so that you will understand what is PCB designing is. Okay, these are the workshop contents. Okay, these are the concepts that will be covered during these 2 weeks. Okay, first one is electronics. There will be nothing much about electronics because all of you are from the electronics background, I think so. Okay, just we will discuss about what is electronics and so on, and we will discuss about PCBs and how they are made, and you will be learning how to design PCBs. Okay, by the end of the session you can be able to design your own PCB, and if it is possible and if you have all the infrastructure needed, you can design your own PCBs. Okay, and you will be learning history of PCB, different types of PCBs, and different layers of PCBs, next different parts of PCB, and you will be taught about the manufacturing process also. Okay, you will be learned about manual manufacturing process of PCBs, not the industry based, because we are not dealing with the industry process. And software explanation. Okay, this course is mainly online, right? Okay, if it is offline, then we can practice hands-on session, but we are dealing with only software side for these 2 weeks. Okay, in this PPT, in the last few slides, you will have some applications of PCB. Okay, is that clear for everyone?
Yes, sir.
Yes, sir.
Okay, thank you, Mr. Okay, Mr. Devaka, is it audible now? Mr. Devakar. Guys, is it not audible for him only? Guys,
It's
please
audible,
respond.
sir.
Okay, thank you. Okay, check your internet connection, Mr. Devakar. Okay, we'll move on to the next slide. Okay, we will not go deep into the electronics background because this is very much familiar to everyone. Okay, electronics means the study of flow of electronics in electrical circuits. Okay, I think it is known to everyone which are in the class today. Okay, mainly electronics is used for information processing and signal processing. Okay, this is the foundation and entire usage of electronics. Okay, these are the two important applications where electronics is used. Okay, it is used only for information processing and signal processing. Okay, that is the major usage of electronics, and there is nothing much to say about electronics because you already know. These are some points related to electronics, and don't worry about the theory parts. We will share the PPT with you after completion of the class. Okay, moving to the next slide. Types of boards. Okay, the first one comes to breadboard. Second one is general purpose board or dot matrix PCB, and the last one is PCB. Okay, printed circuit board. Okay, the first one is breadboard, right? I think everyone are familiar with it. Okay, how does a breadboard is used in our labs? Can anyone define? Why do we use breadboards and how they are used?
Sir, it is for connecting a circuit temporarily.
Okay. Thank you for responding, but all of you make sure that there is no disturbance while you are responding. Please check your fans and etc. Don't create noise while you are speaking. Okay, the breadboards are mainly used for connecting circuits which are not permanent, right? And breadboards are used only for designing simple circuits. Okay, like in your laboratories, I think you have designed. Mr. Burra Dhananjaya. Okay, do you want to speak anything? Okay, unless it is required, then only turn on your mics. or else don't turn on your mics. Whenever I ask a question, then you can respond. Okay, if you have any queries or questions, you can ask me or you can respond in the chat box also. Okay, the first one is breadboard, right? It is used for making simple circuits. Okay, many of you have done so many circuits like amplifier circuits or etc. Okay, is it possible for making large circuits by using breadboards? Suppose if you are doing a CE amplifier characteristics in your lab, okay, there will be only few components like one transistor, 2 or 3 capacitors and few resistors. That's it. Okay, nearly 5 to 6 components. Okay, you can easily connect that circuit by using breadboards. Okay, suppose if I need a motherboard to be constructed on a breadboard, is it possible? There will be number of components like ICs, okay, processors, okay, etc, etc. Is it possible for me to design that circuit in breadboard? That is not possible, right? Okay, so if at all, if I try to do that circuit also, I may design the circuit, but I may find some difficulties like short circuits or some loose connections. Okay, if I connected a wrong connection to the ICs, the whole circuit may give wrong output. Okay, that is the reason the breadboards are not used for large circuits. Okay, coming to the general purpose boards, in the following slides you will clearly understand what are these three types of boards. Okay, the last one is PCB, where I forgot to differentiate these two. In breadboard, for connecting the components we use electrical wires, right? From one terminal of component to another terminal of another component we use electrical wires. But in PCBs, for connecting the component terminals we use a copper track. Okay, that is an electrical connection from terminal to terminal, but it is made of copper. Okay, keep in mind, you will clearly understand in the following slides, don't bother about it. Okay, moving to the next slide. Okay, these are some points related to the printed circuit boards. Okay, if you read out, you can understand easily. The first point says that a mechanical solution to an electrical problem. Okay, can anyone explain what does this mean? A mechanical solution to an electrical problem. I have already explained in the previous slide.
Yes, sir. Sir, if we connect a circuit directly without using PCB or breadboard, so we may get short circuits. Okay, something else. Okay, so for that, so to solve that problem, so we are providing some mechanical support to the circuit, that is by using PCB.
Okay, very good. Thank you, Mr. Okay, in the previous slide, I have explained about breadboard and PCB, right? In breadboard, for simple circuits, it is very easy for us to design. But when it comes to large circuits, we may find some difficulty, right? Okay, I will just show you an image so that you can understand easily. Okay, is my screen updated? Can you observe the image? Please respond.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Okay, thank you. Okay, now observe the image. This is a complex circuit, nothing but a large circuit made up of some wires and breadboard, right? Okay, imagine that if there are some loose connections or short circuits in this circuit. Okay, is it possible for us to identify easily? Okay, it takes more time and our efforts can be useless. Okay, if there are some short circuits or some loose connections, we will not be able to find the errors immediately. Okay, is it possible for us to identify the mistakes or errors? Not possible, right? Okay, it takes more time for identifying the faults in this circuit. Okay, that is the reason the breadboards are not used for making large circuits. Okay, I think it is clear now. Okay, we will go to the PCB PPT. Okay, I think the first point is clear for everyone, and if you read out the remaining points, they are also simple. You can understand. It is a circuit board with printed copper layout connections. Okay, I have already explained you about this point also. In breadboard, we use electrical wire from connecting the terminals of components, whereas in PCB, we directly give a copper track. Okay, from terminal to another terminal of components, we use copper track. Next, PCBs are the backbone of electrical devices. Okay, can anyone give me the applications of PCB in our day-to-day life? Where can we find PCBs in our day-to-day life?
Sir, in every consumer gadget or electronic equipment or electrical equipment, everywhere PCB will be available. PCBs are equipped.
Okay, thank you. Any more answers? Any more devices? Okay, that's good.
Sir, we
Every
will find
electronic
in TVs, TV remotes, and mouses, laptops, and everywhere, sir. In most of the electronic devices.
Okay, thank you. Thank you, everyone. In every electronic device, we come across some PCBs, right? Okay, the daily usable devices like TV remotes, AC remotes, okay, fridges, washing machines, okay, etc. ovens, everything is made up of by using a PCB only. Okay, without PCBs, there is no electronic component nowadays. Okay, that is the reason they are called as the backbone of electrical devices. Next, printed circuit boards are one of the most important parts on electrical and electronic devices. It is also similar to the previous point. Next, electronic boards that connects the circuit components. Okay, PCB populated electronic components is a printed circuit assembly. Okay, now coming to the okay, you can observe two images, right? In the bottom side of the image, you can observe two images. Coming to the left side image, okay, you can observe some black lines, right? And some rectangular shape and round shape holes, right? These black lines are called as copper tracks, and these shapes you observe are called as pads. Okay, these round shapes and rectangular shapes are called as pads, whereas these black lines are called as copper tracks. Okay, in the following slides you will clearly understand what they are and how they are made. Now observe the image on the right side. Here there is a PCB and a component. Okay, I think everyone know what is this component is. I think everyone are familiar with it. Okay, no need for me to explain the component name. Okay, some component is placed on top of a PCB. Okay, always the PCBs will be in green color only. We will discuss it later. And these are two component terminals, right? Whatever may be the component, whether it is a resistor or capacitor or whatever it may be, every component will have terminals, and the soldering areas where we solder the terminals of components are called as pads. Okay, where we solder the component terminals are called as pads. Keep in mind. and in the following slides you will understand clearly. Okay, moving to the next slide. Some key points of PCB designing. Okay, the first one is FR4 board. Okay, FR4 board is nothing but the PCB board. Okay, the designing material is called as FR4, and the FR4 is a combination of Mr. Ram Mohan. Do you want to speak anything? Okay, guys, please be aware of your mics. Don't turn on them unnecessarily. You are disturbing the class. Okay, FR4 board is nothing but the designing material. Okay, and it is a combination of three materials. The first one is fiberglass, second one is epoxy, and the last one is waste cloth material. Okay, don't forget these materials which are used for designing the PCB board. Okay, FR4 board is nothing but the designing material, and it is a combination of three. The first one is fiberglass, second one is epoxy, the third one is waste cloth material. Okay, coming to the next one, copper. As we have already discussed, the connection between component terminals is done through a copper track. Okay, coming to the next point, solder masking. Okay, solder masking is nothing but a protective layer on top of the copper tracks. Okay, which is used for protecting the copper tracks. And I think everyone have observed PCB boards, right, in your homes or in your laboratories. I think all of you have looked at some PCBs in your life. Okay, there will be nobody that haven't noticed a PCB. And all the PCBs will be in green color only. Okay, can anyone tell me what is the reason behind it? If you have gone through Google, you will find the answer. Okay, there is no.
Sir, PCBs are made up of material called glass epoxy resin, sir. It is naturally green in color, so they will be in green.
Okay, thank you. Okay, what we are discussing, solder mask, right? Okay, every PCB will be in green color only, and you can observe PCBs of other colors also. There is no specific reason for using green color. For protecting the copper tracks, they use a layer. Okay, that layer is called as solder mask. Okay, and every company from the beginning they are using green color mask, and nowadays also they are using green color only, and some other manufacturers use different colors also. You can find other red color or orange color like that. There is no specific reason for using green color. That is just a protecting layer of the copper tracks. And coming to the silk screen or overlay, silk screen is nothing but, okay, some designers or manufacturers want some manufacturers use their logos and their factory symbols, some labels on the PCB board. Okay, and their names also. That is called as silk screen or overlay. Okay, you will know what is silk screen in the designing process. Don't bother about it. And we will discuss later about layer stack-up. And coming to the component package. Okay, in PCB designing there are two component packages. Okay, they are the please be aware of your mics. Okay, there are two types of component packages in PCB designing. Okay, the first one is called as through-hole technology or through-hole component package, and the second one is surface mount technology. Okay, the first one is through-hole component package, or second one is surface mount package or technology. Okay, you can call both the names, surface mount technology or through-hole technology. And coming to the pads, I have already explained you. In the following slides, you will clearly understand the component packages and pads, copper tracks, everything, because each and every step will be covered in this PPT. Okay, next, pads. I have already told you that pads are the locations where we solder the component terminals, and copper tracks are nothing but from one terminal to another terminal we give the electrical connection. Okay, either it is positive supply or negative supply, we give the electrical connection, right? That connection is called as copper track. And coming to the plated holes or vias. Okay, in the following slides you will clearly understand what is a vias is. Okay, now observe the image on the right side. This is the PCB board, right? If you generally look at a non-manufactured PCB board, okay, it will just look like a plastic sheet and copper clad on one side. And here you can observe that FR4 board. Okay, this is the PCB board, and on the bottom side you can observe a copper layer, and on top of the copper layer you can observe green color light. That green color is the solder masking, okay, or solder resist, that is used for protecting the copper tracks. Okay, we have discussed about component packages, right? There are two component packages in PCB designing. The first one is through-hole component package or through-hole technology, where the component will have terminals, and those terminals should be soldered on the copper side, and the PCBs have to be drilled. Okay, we need to drill the holes through the PCB in through-hole technology and place the component on top of the PCB, and we need to solder the terminals on other side. And coming to the surface mount technology, where there is no need for drilling a holes. Okay, in surface mount technology the component terminals can be directly soldered on the top side of our PCB. Okay, is this slide clear for everyone? Please respond.
Yes, sir.
Okay, thank you. Moving to the next slide. Okay, here is the history of PCB. Some few points related to the history. They are first invented by a scientist called as Paul Ehrler. Okay, during the Second World War time, he designed a PCB board, and it is used in military application, not for general purpose. He designed it for a military operation, and it is used in a rocket launcher. And the third point says that since 1929, PCBs have been mass produced for commercial applications, and they were first used in transformers and capacitors. Okay, these are some points related to the history. Okay, the engineer name is Paul Ehrler. Okay, don't forget it. Moving to the next slide. Okay, here are the types of PCBs. There are two types. The first one is dotted PCB or dotted matrix PCB. The second one is layout PCB. Okay, I think many of you have worked with dotted PCBs, right, in your laboratories. Did anyone work Please respond. Did any one of you work with dotted PCBs?
Yes, sir.
Sir.
Okay, thank you. Thank you for responding. In dotted matrix PCBs, there will be some holes and surrounded by some copper pads. Okay, nothing but we need to place the components and we need to solder them with some electrical wires. Okay, this is just an extension to the breadboard connections. Okay, in breadboard we have temporary connections, whereas in dotted matrix PCBs we can place the components and we can solder them directly to the dotted matrix PCB. Okay, is that clear? Whereas layout PCBs, okay, in layout PCBs, by using some of the PCB designing softwares, we will design the layout of our circuit and then we will take the printout of that circuit and print it on a PCB board. Okay, where there will be no short circuits or short connections. If you observe the left side image, that is a layout PCB. Okay, the design is called as layout, where we need to make all the electrical connections with a copper track. Okay, moving to the next slide. Okay, these are some points related to the dotted PCBs. Okay, in dotted PCB boards, only dots are available. Okay, this is already known to all of you. According to our requirement, we can place or insert the components in those holes and attach the components with wires and soldering lead. Okay, as I have already told you, we have to place the components in these holes and we need to solder them with some electrical wire. Okay, it is very hard to design, as you know, and the difficulties are there is a chance of getting short connections or loose connections, and that is a drawback of dotted PCB. Moving to the next slide. Coming to the layout PCBs. Okay, layout PCB is to design nothing but by using some of the PCB designing software. We will design the layout of some circuit. Suppose if you have the circuit of a CE amplifier or CC amplifier, think like that, and we will design the layout of that circuit. Okay, if you observe the image, we will place the components and we will design the layout of that circuit first. Okay, then we will take the printout of that circuit and that printout is again printed on the PCB board. Okay, you will be knowing how they are made, and if you read the points you can understand. First we select our circuit and using different PCB design softwares design the layout of the circuit, and by okay, there is a mistake here guys, just a small correction. This is not etching, that is ETCHING, etching process. Okay, Mr. Revan, do you want to speak anything? Guys, please be aware of your mics. Okay, this is ETCHING, not ITCHING. Okay, by etching process, preparing the copper layout of the circuit and solder the components at the correct places. Okay, you will know how the etching process is made, and some advantages of layout PCBs are it is simple to design. Okay, it takes less time, no short circuits, and it looks nice and perfect. Okay, these are the advantages of layout PCB. Next, coming to the next slide. Okay, types of PCB designing layers. Okay, PCBs are made with different layers. Okay, depending on the circuit size. Okay, If the circuit is small, we can design it in single layer, and if the circuit is very big, we can go to the next layers like double-sided PCB or multi-layered PCB. Okay, depending on the size of the circuit, the layers increases. Okay, coming to the single-sided PCBs. Okay, single-sided PCBs are nothing but there will be a copper layer only on the top side of our board. Okay, the back side will be looking as a plastic sheet, which is the FR4 board. And when coming to the double-sided PCBs, we will have the copper layer on both the sides. Okay, and they are separated with a insulating material that is nothing but the FR4 board. Okay, if you read the points, base material clad with copper on one side. In single-sided PCBs, only one side is copper. The remaining side will be FR4 board. Okay, double-sided PCBs. The assembly encompasses a base material with copper on both its sides. Okay, I think it is clear. In the following slides, you will clearly understand what is a single-sided and double-sided PCBs. Coming to the multi-layered PCBs, there will be several layers of copper as well as insulating material. Okay, and some other types are aluminum backed PCBs, flexible PCBs, rigidized flexible PCBs. In the next slides, you will understand what are they. Don't bother about them. And after completion of the class, I will share the PPT with you. You can read them. Okay, observe the images carefully. You can understand what are layers. Okay, in single-sided PCBs, you have only one copper layer and substrate is nothing but the FR4 board. Okay, and on top of your copper layer, we will have the shoulder masking layer. Okay, this is single-sided PCB. Coming to the double-sided PCBs. Okay, we will have two copper layers. Okay, and we will have only one substrate. Substrate is nothing but the insulating material between the top layer and bottom layer. Okay, and for two layer or double-sided PCBs, we will have two shoulder maskings. Okay, for two copper layers, because we need to protect both the copper layers either on top or bottom. Okay, vias. Okay, we will discuss about vias in the following slides. In this image, you cannot understand clearly what is a vias is. And coming to the multi-layered PCBs. In multi-layered PCBs, we will have several layers of copper and several layers of substrate. Okay, substrate is used for insulating between the copper layers. Okay, for separating the copper layers, we need to use the substrate in between them. Okay, and multi-layered PCBs or double-sided PCBs, we will have only two shoulder maskings. Okay, nothing but on top layer and on bottom layer, we will have only two shoulder masking layers. Okay, is this slide clear for everyone? Guys,
Vias
please
is
respond.
what, sir?
Okay, in the following slides, you will understand. I will explain in the following slides. Okay, don't bother about it. Vias is nothing but electrical connection between layers. Okay, if I explain it in here, you may confuse. In the following slides, you will have clear images of vias. Okay, don't bother about it. Vias is nothing but an electrical connection between layers. Okay, moving to the next slide. Okay, coming to the flexible PCBs. Flexible PCBs are nothing but they can be bent, okay, in a direction the user wants. Okay, Can anyone give me an example of a flexible PCB? Or did anyone observe a flexible PCB in any one of your electronic gadgets or devices?
Flexible displays.
Sir, flexible phones, folded phones, folded mobiles. So in folded mobiles, we can find the flexible PCBs.
Okay,
Or
very
even
good.
in
Thank you.
TVs also.
Yes, you will find flexible PCBs in many gadgets. Okay.
Laptop
Yes.
also, sir.
Okay, I will explain it with an example. I will explain. I think many of you have been to a mobile repairing shop, right? Okay, I think many of the boys would have gone to a mobile repair shop, and when your smartphones are open, okay, the motherboard and your display, okay, mobile display is connected with a flexible PCB. Okay, if you observe clearly, your display is connected to your motherboard of your mobile with a flexible PCB. Okay, that is a flexible PCB you can observe. And coming to the some of the examples that you have given, okay, like folded mobile phones and laptops, okay, those comes under flexible rigid PCBs, okay, because they will have some rigid portion along with flexible portion. Okay, if you think clearly, you can understand what is the difference between a flexible PCB and a rigid flexible PCB, because in flexible rigid PCBs we will have some solid portions. Okay, consider your laptop as an example. Okay, in rigid portion your motherboard will be present of your laptop, and in the flexible portion your display will be. Okay, is that clear? Your display is a flexible portion, whereas your rigid portion is the motherboard of your laptop, which is present under the keyboard. Okay, is that clear? And did any one of you observe flexible PCBs of your mobile phones? Guys, please respond if you do so. Okay, we will move on. And coming to the rigid flexible PCBs, these are similar to the flexible PCBs. Okay, there will be no much difference between flexible and rigidized flexible PCBs. And I have forgot about the aluminum backed PCBs, right? Aluminum backed PCBs are nothing but a aluminum backing will be provided to your PCB board. Okay, nothing but in high power applications there will be a aluminum backing, nothing but a aluminum layer for protecting the PCB is present, and these aluminum backed PCBs are used only for high power applications. Okay, high power applications are nothing but, if you consider your CPU motherboard, it is a aluminum backed PCB because it have to stand high power. Okay, that is an example of high power applications. And moving to the next slide. Okay, these are the clear description about single-sided, double-sided and multi-layer PCBs. Okay, in single-sided PCB, as we have already discussed, there will be one copper layer on top of the board. Okay, if you read out the points, the most basic PCBs have the components mounted on one side of the board and the conductor pattern on the other side. Okay, if you clearly read this point, you can understand what is a single-sided PCB is. Okay, because in single-sided PCBs, components will be mounted on one side and the other side will be the copper pattern. Okay, conductor pattern or copper pattern is the same. Okay, nothing but there will be one layer of copper, and on the other side we will place the components. Okay, because there is only a one conductor pattern on one side, this type of PCB is called a single sided or single layer. Okay, and it is suitable for only simple circuits. Okay, and the last point says that it is the start point of invention. Okay, nothing but single sided PCBs are also used nowadays. Nothing but also they are invented during 19 earlier days, nothing but 1920 or 1919 like that. Nowadays also we are using single sided PCBs. Okay, that is the meaning of the last point. Okay, it plays a major role in the industry today also. Okay, observe the image. In single sided PCBs we will have only one copper layer. Okay, observe the right side bottom image. Okay, that green color is the PCB board or FR4 board, and on the bottom you can observe copper layer, right? That gold color is the copper layer. Okay, you can observe that copper track, and you can observe two holes, right? Those holes are used for placing the components. Okay, and components are placed on the opposite side of copper layer. Okay, don't forget it. Always remember that your components will be placed on opposite side of our copper layer in single sided PCBs. Okay, when it comes to double sided PCBs we can place the components on both the sides. Okay, and the terminals of components will be soldered on the copper side. Okay, is this slide clear for everyone? Can I move to the next one? Okay, I think I have a question. Mr. Rahman, I have already given you an example of aluminum back PCB. Okay, the example is your CPU motherboard. Okay, they are aluminum back PCBs. Okay, for high power applications only we use aluminum back PCBs. Okay, can I move to the next slide? Please respond.
Okay, sir. Thank you, sir.
Okay, thank you guys. Moving to the next slide. Double-sided PCBs. Okay, these are some extension to the single-sided PCBs. Just we will have copper on the bottom side also. Okay, we will have copper on both the sides of PCBs. Okay, if you read out the points, you can understand clearly. Double-sided PCBs are better suited for complex circuits. Nothing but single-sided PCBs are suitable for simple circuits, and double-sided PCBs are used for complex circuits. Okay, wherein parts and components are attached both the sides of substrate or board. Okay, in double-sided PCBs have a conductor pattern on both the sides of the board. Okay, having two separate conductor patterns requires an electrical connection between them. Okay, now coming to the vias concept. Okay, when coming to the double-sided PCBs, we need to have some electrical connection between the layers, right? Suppose some component requires an electrical connection between the top layer to bottom layer. Okay, in such cases, we need to provide the electrical connection, right? Okay, that electrical connection is called as a vias. Okay, if you read this point, having two separate conductor patterns requires an electrical connection between them. Such electrical connections or bridges are called as vias. Okay, the vias in double-sided PCBs always penetrate the whole board. Okay, increasing the complexity and density of components. Okay, if you observe the image, these are two copper layers on both the sides, and on the middle you will observe the green color FR4 board. Okay, or insulating material. In the next slide, you will clearly understand vias. Okay, don't bother about it. Moving to the next slide. Multi-layered PCBs. Okay, in multi-layered PCBs there will be several layers of substrate separated by insulation. And in multi-layered PCBs, buried or blind vias will be used because they only penetrate as many layers as in necessary. Okay, you will understand with the diagram. Don't bother about the points. Okay, and the next point says that the multi-layered PCB is the development of double-sided PCB. Okay, if you observe clearly, just a modification in the double-sided PCB, we will get the multi-layered PCB. Okay, nothing but increasing the layers will make it a multi-layered PCB. Okay, increasing the complexity and density of components. Okay, now observe the images on the bottom side. Okay, this is the diagram of a multi-layered PCB where you will find top layer and bottom layer. In between top and bottom layers, we will have other layers also. Okay, other middle layers you can observe in the image. Okay, if you observe the marks here like top layer, bottom layer, and always remember that only the top and bottom layers are used for placing the components. Okay, the middle layers are not used for placing any components and soldering them. Only the top and bottom layers will be used for placing the components. Okay, the middle layers are used for providing only power supply and ground connections. Okay, if anyone asks you about this, just be careful and be aware the middle layers of PCBs are not used for placing any components. Okay, the middle layers, how many layers maybe? Okay, we can design several layers of PCBs. Okay, can anyone tell me how many layers are present in the motherboard of your mobiles, smartphone mobiles? Can anyone give me the answer?
Some millions.
Okay, that is not the right answer. Okay, that is just a single digit number, not millions or trillions. How many layers are present in the motherboard of your smartphone?
Sir, it's two, sir.
Okay, that is also wrong answer. Okay, I will give you the answer. Just your smartphones are made of 8-layer PCBs. Okay, and there is some increment also. But currently the mobile phone motherboards are made up of 8 layers. Okay, that is the general figure which is used for making the motherboards of mobile phones. Okay, like that we will have several layers of PCBs. Okay, currently they are up to designing 116 layers of PCBs also. Okay, that but they are not into market right now. Okay, there will be several layers and we can design as many as layers we want. Okay, just observe the image on the left right bottom side. Okay, these are some middle layers and middle layers are only used for providing ground and power supply connections. Okay, coming to the vias concept. Okay, now if you observe the diagram here, there is a tube-like structure, right, from top layer to bottom layer. Okay, this tube-like structure is nothing but an electrical connection between the top layer to bottom layer. Okay, in this hole we will have conductor pattern, nothing but there will be copper layer in this hole. Okay, this is the vias. Okay, if you observe it clearly you can understand vias is nothing but electrical connection between the top layer to bottom layer. Okay, or top layer to middle layers. Okay, that is the vias. Okay, providing electrical connection to the layers of PCB. Moving to the next slide. Okay, these are already discussed board styles like rigid flex, flexible rigid, and hybrid. Next, parts of PCB. Okay guys, this is not parts of PCBs. Just a small correction. These are some components used in PCBs. Okay, these are not parts. The following slides will be the parts of PCB, but these are not the parts of PCB. These are just some components which are used in PCBs. Okay, coming to the components, they each and every circuit will have these components like active and passive, and all of you are familiar with the active and passive components like transistor integrated circuits comes under the active components. Okay, there is a mistake here. Diode is not an active component. Okay, just make a note that diode is a passive component. Okay, and transistors integrated circuits comes under active components, whereas passive components are nothing but resistors, capacitors, inductors, transformers. All those components will come under passive components. Okay, whatever may be the circuit is, okay, these components are common in your circuits. Okay, whatever may be the circuit, whether it is a small one or big one, these components will be definitely present in your circuit. Okay, moving to the next slide. These are the parts of PCB. Okay, and I think all of you know these parts because we have already discussed about them. Pads, the first one is pads, location where the components solder to. Okay, nothing but we solder the component terminals, and those areas are called as pads. Coming to the traces, nothing but we connect the pads together. Okay, component terminals are connected together with a copper track. Tracks or traces is same. Okay, don't confuse with it. Okay, tracks or traces, it is similar. Okay, coming to the wires, it is responsible for making electrical connection between layers of PCB. Okay, coming to the top metal layer. Okay, if you read this, you will understand the layer where most of the components are assembled. Okay, in top layer only we will place 70 to 80% of the components. Okay, if it is a double-sided PCB or multi-layered PCB, 70 to 80% of the components are placed on top metal layer only. Okay, and fewer traces in the top metal layer. Okay, if you understand this point, fewer traces, nothing but tracks. Okay, in top layer there will be less number of tracks when it compared to the bottom layer. Okay, now if you read the bottom metal layer, fewer components in the bottom layer and many traces, nothing but in the bottom layer we will have more tracks when compared to the components. Okay, is this slide clear for everyone? Can I move on to the next one? Guys, please respond. Can I move to the next one?
Yes, sir.
Okay, thank you. Okay, this is an interactive section, right? If you are active, then we can move quickly. Okay, if you have any queries, you can ask me through the chat box also. Okay, and if it is possible, I will show you I will show you a video of manual process of designing PCBs also. If there is time, okay, we will play a video also in the ending of the PPT. Okay, move on to the next slide. Package types. Okay, we have already discussed about the package types, but here you can understand it completely by looking at the diagrams. Okay, PCB components can be mounted onto the board in two ways. Okay, nothing but component packages are two types. The first one is through hole. Okay, not the surface mount. The first and previous method is through hole technology. Okay, through hole technology is nothing but components with leads or terminals are inserted through the mounting holes, hence the name through hole. Okay, as I have already told you, every component will be present with terminals, and those terminals should be inserted into the PCB board, and they should be soldered on the other side of the PCB. Okay, whereas coming to the current technology, okay, surface mount technology or advanced technology. Okay, this is an advanced technology, guys, and through hole method is the olden version, and nowadays also we use both the technologies. Okay, surface mount is nothing but PCB components are directly mounted onto the board. Okay, now observe the images at the bottom side. You can observe resistors, transistors, capacitors, right, on the right side. These components are through hole components, okay, where they will have terminals, and those terminals should be inserted through the PCB board, okay, and they should be soldered on the other side of PCB. Whereas coming to the left side component symbols, you can clearly observe that these are all surface mount devices. Okay, they can be directly soldered to the top side of your PCB. Okay, I think it is clear for everyone. These are the through hole components and these are surface mount components. Okay, moving to the next slide. Okay guys, these are some PCB designing softwares. The first one is, it is a basic software for PCB designing and it is called as PCB Wizard. Okay, and some other softwares are PCB Web Designer, PCB TinyCAD, okay, KiCad, Jada, Easy EDA, Eagle PCB, etc. Okay, these are all some different kinds of PCB layout designing softwares. Okay, and during these 2 weeks, okay, we will be discussing 3 PCB designing softwares. Okay, the first one will be PCB Wizard, which is a basic software for beginners, and after that we will be working with Easy EDA, okay, which is an advanced tool, and the last one will be Eagle PCB. Okay, we will be covering these 3 softwares during this 2 weeks. Okay, is that clear? PCB Wizard is a basic software and it is very good for the beginners. After that, we will be working with the advanced software, that is Easy EDA, and we will introduce you to the Eagle PCB also. Okay, along with these 3 softwares, we will introduce you to another circuit designing software also, that is called as Livewire. Okay, from tomorrow onwards we will be working on softwares only. Okay, but coming 1 or 2 classes we will not be designing any PCB boards, just we will be working on some circuits. After that, from the next classes we will be going to designing PCB boards for those circuits. Okay, is that clear for everyone? Moving
Yes,
to the
sir.
next slide.
Okay.
Okay, thank you for responding. Okay guys, coming to the manual designing process of PCBs. Okay, this is how we design the PCBs in our laboratories. Okay, not in manufacturing companies. Okay, this is the manual process. Okay, this is the process what we follow for making the students to design some PCBs. Okay, is that clear? Now coming to the manual process, first we will be working with etching process. Okay, these are the steps. Okay, the following slides we will clearly understand. First, we need to take a PCB board. First of all, before designing or manufacturing PCB board, it will look like this. If you observe the right side top image, PCB boards, either they are single layer or double layer, they will be looking like this with copper cladded on entire board. Okay, next we will design the circuit by using some of the PCB layout designing softwares. Observe the left bottom image. Okay, this is after taking the printout from the layout designing software. Okay, consider it is a circuit of some different. Okay, that is a random circuit, and that circuit is layouted by using PCB designing software. After that, you need to take the printout of that layout, okay, by using laser printer. Okay, and that paper is not normal paper, you need to use a glossy photo print paper. Okay, this is the first step that we need to do. Moving to the next step. Okay, after taking the PCB board, you need to clean it first. Okay, if you read out the points, you can understand the process. Score the board with Scotch White Barrett pad, then rinse it with acetone. Okay, this is the cleaning process. Okay, notice the fingerprints on the boards which has not been sorted. Okay, first we need to clean the board with some Scotch White. Okay, if you observe the left side bottom image, you can observe that this is a cleaned copper layer PCB board or copper sheet, and this is the layout printed on the photo print paper. Okay, glossy photo print paper. Now the next step is we need to place the printed layout on top of the copper side of PCB board. Okay, after that we need to place an iron box. Okay, as I have already told you, this is the manual process. Okay, we need to heat it for printing it on top of the PCB board. Okay, we need to heat it for 3 to 5 minutes. If you read the points, use an iron, no steam, on the hottest setting to the iron. Okay, your iron box should be fixed at the highest rating. Okay, nothing but it should be in maximum position. Okay, then the pattern onto the copper surface, press down hard for about 3 to 5 minutes. Okay, 3 minutes is enough if you use the photo print papers, or else if you use some low cost papers, then it will take more time. Then after heating the surface of the layout on top of your PCB, we need to place that in a bowl of water. Okay, and then we need to sit it for 10 minutes. Okay, and we need to allow it for removing the paper. Okay, about 10 minutes it will take time for the entire paper to soak. The next step is just take out the PCB board from the bowl of water, and then you need to slowly clean the paper. Okay, if you rub your finger gently, the entire paper will be removed, and you can observe the layout will be printed on top of your PCB. Okay, that black printout is the layout. Okay, now we have to etch the excess copper. Okay, etching process is nothing but removing the excess copper from our PCB board. Okay, if you read out the points, after soaking, remove as much backing paper as possible with the fingers. Okay, the ink pattern will stick to the copper below. Okay, after cleaning off as much paper as possible by hand, use a toothbrush. Okay, toothbrush is not recommended because if you are a beginner, if you use toothbrush, you may remove the layout also. Just use your fingers to remove the paper. Okay, the ink should not come off the copper at all during the process. As I have already told you, we need to do it gently without removing the layout from the PCB board. Okay, the next step is we need to place this board in the etching solution. Okay, here is a set of board Okay, there are 8 boards that he have prepared and ready for etching. The ink serves as etch mask. Nothing but the black area will be protected and the entire copper area, nothing but the area which is not printed will be etched off. Etching is nothing but removing the copper area, excess copper area. Okay, just I will show you a video, then you can clearly understand. Okay, this etching solution is called as ferric chloride. Okay, if you observe the solution here, that is not water, that is a chemical called as ferric chloride solution, okay, which is used for etching of the PCBs. Okay, you can observe the copper right here. After etching process, the excess copper will be removed from the PCB board. Only the tracks and the area which is in black color will be present on the PCB. The remaining entire area of copper will be removed in etching process. Okay, next moving to the next step. Okay, after taking the board from etching solution, okay, while dealing with the ferric chloride solution, we need to be very careful because it is a harmful chemical, and if you touch the solution with your fingers, you may get some rashes or something like that. And while dealing with the ferric chloride solution, we use gloves for students also. Okay, here is a fully etched board ready for cleaning. Okay, after taking it out from the etching solution, we need to clean it with acetone. Okay, acetone or thinner. We must use kerosene or thinner for cleaning the surface. Okay, after cleaning the board, it will look like this. Okay, if you read the points, you will understand. Use acetone to wash off the mask. Okay, for removing the black color of the paper, we use the acetone. Okay, we can remove it with water also, but it takes more time. And if we use acetone or kerosene or thinner, it will take less time for removing the black paper. Okay, the next step is drill the holes in the PCB. Nothing but at required positions where the component terminals are present, we will drill the holes and place the components on other side of PCB, and we will solder the components on the copper side. Okay, this is the manual process, guys. Do you have any questions related to all these slides? If you are clear, just I will show you a 2-minute video of designing the PCBs. Please respond quickly. Okay, thank you. Just a moment. I will play the video for you. Then you can understand the manual process of designing the PCBs. Guys, is my screen is visible? Please respond quickly.
Yes, sir.
Okay, thank you. I think the audio will not be audible for everyone. Okay, just follow the video. I will explain the process. Okay, if you have any questions, you can ask in the middle also. Just follow the video. Okay, first of all, this is the layout of his circuit. Okay, some random circuit, we don't know the name of the circuit. Okay, he designed it by using some of the layout designing softwares. Okay, we don't know the circuit name. After that, he took the printout of that circuit. Okay, and he took the measurement of that board of his circuit. Okay, that is the cleaning process of PCB. After taking the exact size of your board, okay, you need to clean your PCB. Okay, after that, the printout should be placed on top of the PCB and it should be heated with maximum heat setting on your iron box. Okay, after heating 3 to 5 minutes, the printout will be placed on top of our PCBs. Okay, after that we need to place it in a bowl of water. Okay, we need to leave it for 10 minutes. Okay, then gently remove the paper from the PCB board. Then you can observe that only the copper tracks of paper are present on the copper layer. Okay, you can observe clearly the copper layer is present on entire board. Okay, and after completion of okay, this is the etching solution. Okay, ferric chloride solution. While dealing with it, we need to be very careful. Okay, we need to place the board up to 15 to 20 minutes. Okay, it takes 15 to 20 minutes for removing excess copper area. Okay, here you can clearly observe that the entire board, okay, except some small place, and now the entire board is etched completely. Now we need to clean it. Okay, for cleaning, use acetone. Okay, after cleaning, you can clearly observe that only copper tracks are present on the PCB. Okay, the excess copper area is removed completely. Only the copper tracks will be present on your PCB board. Okay, the last step is drilling the holes at correct positions. Okay, wherever required, we can drill the holes, and after that we need to place the components on the other side. Okay, that is a manual hole drilling machine. of PCBs. The next step is to place the components. Okay, the video is completed. Okay, the video is completed. Do you have any questions? Okay, do you want me to repeat the video or do you have any questions? Please respond quickly. Okay, thank you guys. That is the introduction of PCB designing. From tomorrow, we will be working with softwares. Okay, if you have any queries, you can ask in WhatsApp group also. Okay, registrations, just give me a minute. I will update it. Okay, guys, just 1 minute. We will share the registration sheet with you. Okay, just we will share a sheet. You need to fill that sheet. Okay, just 1 minute. Wait in the meeting. Okay, just look in the chat box. We have posted the sheet to you. Okay, just complete it. Okay, thank you everyone.